Good afternoon, or good evening, and welcome to the wonderful world of Algebra 2. This should be the first of many videos that you will be watching this year. Today, I'm going to start with problems 5, 6, and 7 on worksheet 1.1, day 1 of your Algebra 2 material. So let's zoom in on these problems here. We have to match each scenario with the graph that it could represent. So, the price of a postage stamp over 20 years. Well, the price starts out at a certain price, and then it goes up, and it never goes back down. It certainly doesn't decrease, so this must be it. But how is it increasing like this, as a step function? Well, at some point it's a certain price, and it stays that way for a year or two, and then all of a sudden they decide to raise the price, and it stays that way for another year or two or 6 months, and so forth and so on. So, number 5 would be letter C. It would match letter C. The description is you have a price increase every few years. Now, the number of hours of daylight each day over a year. We are, of course, assuming the northern hemisphere. Well, in January, winter time, in the northern hemisphere, we have short hours. The sun rises at 7 o'clock and it sets about 4:30 or 5 o'clock. And of course, if you recognize in summertime, it sets a lot later. So, you increase in hours. But then as you go back towards winter time at the end of the year, it goes back down as a number of hours. So this would be your best representation. You have increasing hours until you hit the middle of summer, and then you have decreasing hours until you get all the way back to the end of the year. And of course it stops because this is over a 1-year period. So this would be graph A, and the description is the hours increase daily until the first day of summer, actually, which is July 21st, I believe, until July 21st, then decreases until the end of the year. End of the year. The value of a car over 10 years. Well, let's see, you buy it, so that must be answer B, but let's make sure it makes sense, because maybe the answer should be none of the above. Well, let's see if it actually is. Okay, so you buy a car at a certain price, and of course as soon as you drive it off the lot, it decreases in value, and it continues to decrease in value. But even if it's 20 or 30 or 40 years old, you can usually get a few hundred to maybe $1,000 for it, so it seems like it kind of never ends. So this one would be graph B. Okay? Value of the car decreases over time. Decreases over time. Okay, we were also supposed to label the X and Y axes. So price of a postage stamp, these would be the year, and this would be the price. For graph A, this would be the month or the time, and this would be the hours. And of course this one here for graph B, value of the car that decreases over time. So this would be the value, and I'll use dollar signs to represent it. Maybe I should put $3 or $4 signs because cars are fairly expensive, and this of course is time. And thank you very much for your time.